So we're going to just do a little practice graphing today and tomorrow, and then next week we're going to revisit the word problems, but they're going to start getting a little more elaborate, and we're going to need some prior skills such as graphing and standard form to solve them. So I want to go back and practice this first for a few days, and then start the word problems again next week. Okay? So let's just go do a few. If you think you know how to graph on all these, you probably do fine on your own. Just remember, you need to use a straight edge. Okay, so all your lines should be using a straight edge. You can even use like the side of the Chromebook, something straight. It doesn't have to be a ruler. You're not measuring anything, but just something that's straight. Even folding a piece of paper a few times will make you draw a straight line. So use some sort of straight edge when you're graphing these. Because the answer for all of these are going to be, where do they intersect? So if your lines are not straight, they will intersect at the place where they should for it to be the right answer. So that's why it's absolutely necessary to have perfectly straight lines here. Otherwise, they won't intersect at the right place. So let's just start graphing these. Just to recall, if they don't give you a slope, or they give you a slope that's just a number, make sure you make it over 1. All right? Start at the y-intercept. In this case, it's -4. So remember the y-axis is right here. 1, 2, 3, and 4. All right? And then use your slope. Go up 2 and right 1. So just do that a few times. Up 2 over 1. Up 2, right 1. And then once you've done it a few times, use your straight edge to draw a line across the entire graph. You don't know where the other line is going to intersect, so make sure you draw that line across the entire graph from one end to the other in the perfectly straight line. Because we don't know if it's going to intersect down here, or in the middle, or up here. You don't know where it's going to cross, so you need to draw that line across the whole thing. All right? And then we can do the same thing for the next one. Remember, negative x is the same as -1 over 1. Start at -1 this time. And you're going to go down 1 and right 1. So down 1, right 1. There's the intersection. We'll just do it a few more times. Go across the entire graph. And then using a straight edge, you go from one end to another. So as you see the screen right now, that is not the right answer. You're not finished with that problem. That's not it. Okay? So again, the answer is, where do they intersect? That's the answer. So the last thing to do is going to be to say these intersect at, okay, the x-axis is at 1. So they intersect at 1, comma, and right here would be down 1, 2. So the answer is 1, comma, -2. And that's your answer. For each one of these, you should have an answer that looks like, that is a coordinate. Now, there is a possibility that the two lines don't intersect, and then you'd have a no solution. But I think for everything today, there should be a solution for every single graph. Okay? So the answer is the intersection. If your lines aren't straight, they won't cross at the right place, and you'll have the wrong answer. So make sure you use a straight edge. At least fold a piece of paper a few times. Do that. Let's recall some of the special cases here. So what does the line y equals 2 look like? Is that horizontal or is that vertical? What is y equals 2? And if you forget, just remember it's y, right? And you go to the y-axis and you go to 2. So that's right here. And hopefully that helps you remember that, okay, y equals 2 goes and crosses the y-axis at 2. That's why it's called y equals 2. So y-axis at 2. So that's a y-intercept of 2 with a slope of 0. Doesn't go up, doesn't go down. And then we have the other part that, well, what does x equals 4 look like? So that means it crosses the x-axis at positive 4. 1, 2, 3, 4. Which must mean it's a vertical line. Okay, is that the right answer for this problem? Do you see an answer on there yet? No, I haven't even written an answer. So the graph is not the answer. Make sure you say the answer is going to be a coordinate. These intersect at 4, comma, 2. This is x equals 4. This is y equals 2. So the answer, this coordinate is 4, comma 2. You got to have that on there. Otherwise, you have not finished the problem. Let's review a little bit on number 7. So you can see the first one is in slope-intercept, the second one is not. And this is what we really want to practice today a lot is, if it's not in slope-intercept form, you want to change it up. So let's do the first one that's already done for us. Start at positive 2. Okay. And we're going to go up 1, right 4. Up 1, right 4. Do that a few times. And then use a straight edge. Do that one. And then we have to remember how to graph the second part. That's not in the slope-intercept form. So recall that we're trying to get y equals mx plus b. So we need to get this y by itself, which means I need to move this 2x, and there's also a negative sign. So there's 2 steps here. First, get rid of the 2x, and then the negative sign. So step 1, it's a positive 2x here, so let's subtract 2x. So this cancels out 0. Then we have left over is minus x. And then we have negative 2x plus 5. Remember, always put the x part first. So instead of doing 5 minus 2x, put negative 2x plus 5. And then lastly, let's get rid of that negative, which is the same as negative 1. So this is negative 1 times y, so undo the multiplication by divided by negative 1. Divide by negative 1. So we have an answer of y. 1y, because negative or negative is positive 1. Let's cancel out. Negative 2 divided by negative 1. 2. And you can make that an over 1, 2 over 1. Negatives cancel out, 2 over 1. And 5 divided by negative 1 is minus 5. Positive divided by a negative is a negative. Alright, so let's graph this one. Start 0. 1, 2, 3, 4, 5. Up 2 over 1. Do that a few times, and you can see you might end up crossing the line at some point. Good. That's your answer. But still, make sure you use that straight edge. There we go. So what is the answer? Where do these intersect? What's that coordinate right there? We have, let's see here, 1, 2, 3, 4 to the right. So x is 4, and then up 1, 2, 3. So the solution is 4, comma 3. it over to the back to number 12. Go ahead and graph the first one on your own. I'm going to kind of come around and check to make sure you can do some of these on your own. So graph the first equation on your own. Reminder, should that negative go to the top or the bottom, or does it matter? Doesn't matter. As long as it goes to one or the other. You don't make both negative. If you have one negative, you can put it one place. Start at 3. And you can either go down 1, right 2. Alright, you put the negative on the top. Maybe down 1, right 2. Or you can put the negative on the bottom, and then you go up 1, left 2. So either way, you'll get the same thing. If I go down 1, right 2. Or if I go up 1, left 2, you see you get the same exact line. So it doesn't matter what direction you go in. And then solve the second one for y's. Go ahead and solve the same second one for y, just like we did on the front. And graph that one, and let's see where it crosses. The conclusion here. So if you go ahead and graph this, look up here. If you go ahead and graph this, you end up with 4y equals negative 2 plus 12. And when you divide everything by 4, y equals, I reduce 2 over 4 to 1 over 2. Add 3 to that. That's 12 divided by 4 is 3. And you'll notice right here that these are the exact same equations. Right? It's the exact same line. So this is something new. What do you do if your answer is where they intersect, right? What if they intersect at every single point? Yeah, then you can say all real numbers or infinite solutions. Because if the answer is where they intersect and they intersect anywhere, that's an infinite number of answers. They intersect everywhere. Okay? So we could say, yeah, either all real numbers are answers, or infinite solutions, something like that. And what if they did not intersect at all? Yeah, if you had two lines and it kind of looked like this, and they're never intersecting. If you had two lines that never intersected, you could say, well, there's no solution whatsoever, right? Okay. For the last ones, just remember your equation, your answer is an equation. So it should start off with y equals 3x, and then some y-intercept after that, okay? All right, leave you two guys to work, and we'll do a little bit of this today and tomorrow to wrap up the week. If you weren't here yesterday, we did take a test, so you need to make that up if you were not here yesterday. On number 10, please change this to a 9 right here. Change that to a 9. It'll come out to a fraction otherwise, so let's fix it.